Today we're going to look at activities. We'll start by talking about what an activity is and how you use it. Then we will look at some of the ways that you can start and stop an activity. Following that, we will look at intents and context as a way to facilitate communication between activities. And lastly, we will look at the activity lifecycle as well as some of the considerations that will impact its use. So starting from the top, what is an activity? An activity is one of the four top level components in an Android application. It is the component charged with presenting the user with a screen and presenting them with a user interface, allowing them to interact with your application by triggering events on views as well as getting feedback from your app. On a technical level, the activity class is the superclass of all activities in your application. So you create an activity by inheriting from the activity class or one of its subclasses, such as the app compat activity. This is done for you automatically if you generate an activity from within the IDE. When designing an application, it's considered best practice to have single activities perform a single action or operation. It's not considered a good design to overload activities with multiple types of tasks, disparate tasks. So, for example, you could imagine building an email application where one function in your application is to read emails. Another is to send emails, and another would be to just see a list of messages in a folder, such as your inbox. So one possible design approach would be to have one activity for each of the functions I just detailed. You could have your main or starting activity essentially just be your inbox or the list of any folders. Selecting an email would then launch the email reader activity. And then from there, I could click on, say, reply or forward, and that would launch my email compose activity. And then we can have information being passed between those activities depending on what action is being triggered. And we'll see how that is done a little later on. Generally speaking, applications tend to consist of one or more activities. This is common practice, but it is not a requirement. The four top-level components of an Android application are activities, services, content providers, and broadcast receivers. Technically, for you to have a valid Android application, you need only have one of those components to do something. But since it is the activity's job to show the user something on the screen, oftentimes an application will have an activity, even if broadly speaking, most of what the application is doing can be facilitated with the other top level components. So again, we usually have one or more activities, but it is not required that you actually have any. When you do have activities, one of those activities is usually delegated as the main activity. This is essentially can be thought of as your default screen. It's the screen that gets launched when the user launches your application from the home screen. Now, there's a whole lot of technical details behind that, but that's the simplest way to think about it. When creating an activity, there must be an entry for it inside your application manifest. This is the case for all top-level components with a few exceptions for a few use cases. When specifying an activity entry in your app manifest, the tag must include the Android name attribute. That is the only required attribute. However, there are many other attributes that can be specified. Additionally, when an activity is declared, any property that is not explicitly specified for that activity as an attribute will be inherited from the parent. In this case, it would be inherited from the application tag. So any property such as a label or a theme or an icon that is not specified explicitly for an activity would simply be inherited inherited from the application. So we could take a look at an example of that. Here we see manifest with a default activity declared, and there are properties specified in the parent application tag which will be inherited by the activity, such as label, icon, and theme. If we wanted them to be specific to this activity or different from what is specified by the application tag, then we would explicitly add those properties ourselves. For example, I could specify my own label. If I did not want the label of my activity to be the item specified in application. So we'll come back to this and see exactly how that can play out a little later on. Now, in order for an activity to run, it must first be started. When a user first launches your application from the home screen, your main activity is actually started by the system, allowing the user to interact with it. From there, you can start other activities by either making a call to the start activity function in situations where you simply want to launch an activity but you do not care about its eventual execution or what it's doing, and I'll explain in more detail what I mean in a moment. Or you can use what we'll call for now a launcher, which is a way that you can launch an activity and be informed of information relating to that activity when it has completed doing its work. So you can essentially have that second activity send information back to the original caller. So we'll see how that works as well. In the cases where you want to launch an activity, you need to first create what's called an intent. For now, it is easiest for us to think of an intent as simply the mechanism that specifies which activity we want to start. We're going to see later on that an intent is actually more broad in its capabilities or its uses. But for now, we will simply think of it as the target, the thing that specifies what we want to launch. Depending on how we want to launch an activity, that is, if we want to get information back, we may also need to specify a contract and a callback. So before we look at examples, we just want to be clear that even though you will very often times start activities that are in your own application, it is in no way a requirement that you are limited to launching activities only in your app. Rather, one of the benefits of an Android application is that you can leverage other third-party applications to perform tasks on your behalf. And as such, you can actually start activities from other applications from within your app. So we'll see that in a subsequent lecture, but it is something important to keep in mind. So let's look at exactly what would be required to start an activity. So here we have our main activity. This is what gets executed automatically whenever we hit the run button. If we would like to have a different activity in our application to perform a different task, then we can simply create a new activity, and we can either select the gallery where we're given a dialog to choose, similar to the list of activity templates that we see when we first create our Android applications, or you can simply pick from the list that's available here. So in my case, I'm going to create an empty activity. From here, I'm asked to specify my activity name. So in this case, I'll call this second activity. And I will have a layout file generated for me automatically. This will not be a launcher activity, so I will only have a single main activity. The second activity will be internal to my application, and I'll leave everything else as is. So here I see that I now have two activities, my main as well as second activity. And if I go to my layout resources folder, I can see that I have two layout files. The first, activity main, is what is used for my main activity. Here we can see my main activity is actually using that layout file for its content view. And then I have another layout file, activity second, that was generated for me automatically as well. And second activity is using that layout file to present a UI to the user. So my goal here is to allow an instance of second activity to be launched from main activity. In order to do that, I need to have some way to trigger that action. So what I will do is place a button on my main activities layout. And I will simply automatically constrain that button. The ID is button. I'll change that to launch button. And I will change the text of my button to read launch second activity. Now from here, it's relatively straightforward if my only goal is to launch an instance of second activity. Essentially, I need only get a reference to my view, which in this case is the button, and then I will attach an on-click listener. In this scenario, I don't even need to place the reference to the button in a property or in a variable, because I will not use a reference to the button again. My only goal here is to attach an on-click listener. So this shortcut essentially suffices. Now, what I need to do here is first, I'm going to create an intent. The goal of the intent is to specify exactly what I plan to launch. An intent is a messaging object used to request an action in Android. Generally speaking, one top-level component can use an intent to make a request to the operating system that a message be passed to some other top-level component. Generally, intents are used to do things like start an activity or return results from an activity, as well as to start a service, which is another top-level component, or to send a broadcast that can be received by a broadcast receiver, which is another top-level component. There are two types of intents, and we will deal with this in more detail later on. The first type is what we call an explicit intent, where a target is specified by name. So we specify the component that we are trying to send this message to, or say, in the case of an activity, the activity that we are trying to launch. So that is an explicit intent. An implicit intent is one where a component is not named, i.e., we do not specify a target. Instead, we simply specify characteristics of an action that we would like to be performed, and we leave it to the operating system and or the user to determine which component should perform that action for us. Now, we will talk about explicit and implicit intents in more detail in a subsequent lecture. But for this particular lecture, we are going to look at explicit intents as our method of communicating between two activities. Now, creating an intent is essentially just a property assigned to an intent object. Now, to create an explicit intent where we specify the target, we need to provide two arguments to the intent constructor. We first need to pass a reference to context, and in this case, I am going to use a reference to the activity. And if I want it to be explicit, I could say this at main activity, since that is the name of the activity that this code resides in. And then I'll specify a target. Now, in this case, the target must be specified using a very specific syntax. Essentially, without getting into the nitty-gritty, we're going to use a bit of what's called metaprogramming, which is we're not just using standard language and statements found in the language, but we are referencing the artifacts of the language itself. And that sounds very complex, but it's just a fancy way of saying that when we're specifying a target, we don't specify an object, rather we specify the class itself. So when I want to launch second activity, I reference the second activity class. And in Kotlin, that is done by saying second activity dot and in Kotlin, that is done by saying second activity colon class. And because what we need is not a regular Kotlin class, but a Java class, that is because the Android framework is written in Java, even though we are writing our applications in Kotlin, I need to place .java at the end. Now, this is sort of something I just want to point out because it looks like a quirk. This is not a file or something called class.java. Rather, second activity class is giving us reference to something, to the class instance of second activity. And on that instance, I am accessing the .java property. So that is how I get a Java class from a K class or from a Kotlin class. Now at this point, we are passing in these two arguments. The second argument is a class reference. In Kotlin, we just have to take this as verbatim. This is how we reference classes whenever we need to, and there will be different times where referencing a class is necessary. The first argument is a context reference, and we've been talking about and using context for some time now, but it's a good enough time as any to stop here and kind of talk about what context is, because it is in fact very important. So context is essentially a reference to the application environment or to the operating system itself. You could almost think of a context object as a system object, meaning It is an object that allows us to make calls to the system or to the underlying operating system to perform actions and operations that we cannot write code to perform ourselves, either because we don't have the privilege, the permissions, and the access, or we don't have the technical references. So context objects are used to do things like load activities or other top-level components. We, of course, have seen where context objects are used to create views at runtime. Context also allows us to access application resources or shared or system resources such as storage. So context is a very powerful and useful object. Now, context itself allows us to do these things, but what you are able to do depends entirely on the source of the context object. Essentially, you can get context from any of four places. First, the activity class itself is an instance of context. And we can actually see that in action. If you were to take an activity and look at its source, you'll see that an app-compat activity extends a class called fragment activity. If we look at the source of fragment activity, that extends component activity. If we keep going down this rabbit hole, we'll see that this extends another class called component activity, but from a different package. Keep going, it extends the activity class, which is the original activity class. Keep going, we'll see that this extends context theme wrapper, and context theme wrapper extends context wrapper, and context wrapper extends context. And it is here that you can see all of the system level functions and properties that are used in building Android applications. These are all the things we can't do ourselves, but the context object can. So this is the power of context. And this is what we mean when we say that activity is itself a source of context. Additionally, the service class, which is something we will see in a subsequent lecture, is also a source of context in a manner very similar to the way an activity is a source of context, in that service class is an indirect descendant of the context class. In every application, there is this hidden component called the application, which is an actual object in your application that you can access if necessary. It runs as a singleton. It's always available. And thankfully, it makes our life a little simpler in that we don't usually need to interact with that component. There are special times where it can be useful and sometimes when it may even be necessary, but in the vast majority of cases, you never need to mess around with the application. However, one interesting thing to note is that application is also a source of context. Now, the last source of context is just specified as Android. And why is that one specified as Android? Essentially, there are times when certain top-level components, specifically broadcast receivers and content providers, are instantiated or initiated by the system. And when those components run, they may need to perform certain types of actions, i.e. context-enabled actions. However, unlike an activity and unlike a service, a broadcast receiver and a content provider are not themselves context objects. They do not extend the context class. As such, they could not call any system calls on themselves. As such, when their various the respective callbacks are invoked, Android will actually pass in a context object that those components can use to perform certain types of operations. Now, it turns out that those context objects are the least capable in terms of what they are able to do, whereas the context object presented by an activity is the most capable. It is able to do essentially anything that a context object can do. So the source of a context object is going to impact what it is you can or cannot do. But it is simply important to note that there are just certain operations where you are not required or even able to write the code to perform the action yourself. Rather, you'll use a context object in order to do it. And in our case, what we want to do here is call start a new activity. And it is a context object that is allowing us to do that. And it's doing that in two ways. First is that when we are creating the intent object, this reference to context is being used to figure out the package of this class so that we can derive the fully qualified name, or FQN, of second activity. Essentially, we want to make sure that we get the unique name for this specific class. So that's the first thing that context is doing here. Then the next step for us is to simply call start activity with our intent. Start activity is a function defined on the context class, or defined in the context class. So when we call start activity, we're calling it on our activity class, which is context. So context is being used in two ways here. First, to find the fully qualified name of second activity, and then to actually start the activity. So with this code, we should be able to see an activity be launched. So let's try this out, see what we get. All right, so here we have our activity, main activity being displayed with a button, launch second activity. And if we launch second activity, here we see another screen being presented. I can hit the back button to get rid of that screen, and we're going to talk about what's happening there later on. But if I hit the button again, you can see this. Now, right now, these activities do not have any identifiers that are unique. We can tell one is the main and one is the second activity because one has a button and one does not. But one thing we could do in order to differentiate our activities is set their labels. So if we go to the manifest, we can see that both activities have been added. Here's our main, that was there from before. And here's our second activity. Now, what we can do is add an attribute label. And we can call this one second activity. And main activity. Now what we've done is specify that our activities should have their own labels instead of the label being inherited from the application class. Running our activity, or running our application now, we'll see that our first activity now says main activity in the top left. And when we launch our second activity, it says second activity in the top left. So what is happening when we perform this action? Essentially, what we're doing is from a specific activity, we're calling start activity with an intent. That intent specifies a target. Now, it's important to note here that when we call start activity with a reference to our second activity, let's just, for the sake of this diagram, refer to it as activity B. Activity A is not itself starting activity B. It does not have that capability. What it's doing is essentially making a system call, if you will, to Android to have that action performed on its behalf. The reason why it's important to make this distinction is that there are a lot of reasons why an attempt to launch Activity B might fail. For example, Activity B might not exist, which is oftentimes not the case with explicit intents, since we are usually referencing activities or activity classes that are in our code. But we could also have issues, say, with security. Activity A may not have permission to launch Activity B, in which case the call would fail. Additionally, there might be considerations about whether or not Activity B should be launched, or how the information being delivered by the intent, which we mentioned is a messaging object, how it could be delivered to Activity B. This is something that is impacted by what we call the launch mode in combination with the current state of Activity B, if it exists. So we will discuss that in a little more detail in a later lecture, but suffice to say, when Activity A wants to start Activity B, it only asks the system to perform that action, and then the system makes a determination of if and how Activity B should be launched. We mentioned that an intent is a messaging object. That fact is important because it underpins one of the capabilities that we're able to leverage when we're writing applications and using intents to launch other activities. And that is, we can pass information from one activity to another. So in this case, where we are launching an instance of second activity from our main activity, I am creating an intent to do so. However, I am actually able to place information in that intent that second activity, upon its launch, will be able to extract and utilize in whatever way it chooses. So in order to pass information, what I would like to do is add what's called extra information into the intent. So I can essentially call a put extra function where I will pass in two values. The first will be a string that will be the name of the value being passed, and the second will be the value itself, which can be of varying types, but it essentially covers our standard primitive types, even though in Kotlin these types are all themselves objects, as well as things like parseable and serializable, which we will learn later on, will actually allow us to pass in pretty much any type of object if we have access to the class. If we're defining these objects ourselves, we have a lot of flexibility in terms of what we can place inside of an intent. We also have the ability to pass in arrays of the various types of data that an intent can accept. So essentially, extra information inside of an intent are an arbitrary number of key value pairs where we have a unique name and then some value of a particular type. Now, you might be tempted to pass information inside of an intent using some form like this. And this may seem fine on the surface, but we want to practice good, or we'd like to have good coding practices here. And one of the things that you should always try to avoid is using string literals as keys or as names. And the reason this is bad is because if you're typing a literal the way we're doing it here, And I subsequently need to reference this name or this key again, which is the case here because you will want to extract the information using the key. It means I would have to retype this key in the second use. And if I'm typing the same value twice, I am opening the door for errors and typos and bugs. As such, best practice when it comes to keys is always to use a reference of some kind. In Kotlin, we have a couple of ways we can do this. And what I'm going to use right now is what is called a constant value. And we define constant values within a class file, but outside of a class definition. The reason it's done outside of a class definition is because it is accessible in global namespace anywhere in your application. So once we define it here, we can actually access the reference anywhere. So if this is, say, message key, and we say this is the value message, then I can simply take message key as defined here, and that is used as my name. And then later on in my application, even in another component, as is the case we're going to see in a moment in second activity, I can use the same key, message key, to access it. And I'm no longer concerned that I'm going to mistype it, because if I were to have a typo in message key, my application would not compile because it would not know that reference. So I'm not going to type an incorrect key unless I type a different key by mistake. That's a little trickier, a little harder to prevent. So we still have to be careful, but at the very least, we're not likely to have a typo in the string, in the actual key itself, that could cause problems that the compiler cannot pick up. So this is how we can place information inside of an intent. And again, you can place an arbitrary number of extra values, even though here we only have one. Once I call start activity, that message will now be delivered. Now in second activity, that value that was placed inside of the launch intent can be accessed via the intent property, where the intent property is a reference to the intent object that was used to launch this activity. Basically, however and whatever launched it would have had to use an intent, and this is a reference to that intent. So it means inside this intent, we have access to a value that we can fetch with a call to get string extra, as you can see here, whereas putting the extra value inside the intent only required that we call a put extra function, which is an overloaded function. When you are retrieving the extra value, you actually need to use the proper getter function, accessor function, where you specify the type. This will allow the information to be cast for you automatically, but it also means you need to know the type of the information you're operating on. So here it's asking for the key, and we need only say message key. You'll notice again there is no namespace here. It's not as if I'm saying main activity dot message key, because constant values have global namespace. It's accessible everywhere in my application. It is not defined inside a specific component. So now I have this message, and I can essentially do with it as I please. For example, if my second activity had a label, which we can give it, let's change the text size to be a little larger. It's for our own purposes. And the current ID for the view is called text view. Maybe I want to call this message text view, just for consistency. Then in my second activity, I can access the property. Let's say I want to do it with a scope function, just to limit the amount of the use of the variable or the explicit casting, I could say something like with find view by ID text view r.id dot message text view. This is going to give me a reference to the text view as the context object. So it means if I want to do something like access the text property, I could just say text is equal to message. So here you will see, even though my text view is only saying text view here, when I run the application, what it will actually do once I launch it is show my message. So clicking the button, launch second activity, will have the message passed to second activity. Second activity extracts the value from the intent that launched it, and then can process it in whatever way it chooses. In this case, displaying it as the text value for its text view. So this is how information can be passed from the first activity to, or the caller, to a second activity or the callee. So activity A can start activity B and pass information to activity B. Now, because we called activity B, or second activity, with a call to start activity, at this point, main activity simply sits in the background waiting for activity B to end. Activity B can be closed in a few different ways. Essentially, activity B, or second activity, can be closed if a user triggers a back action. So that could be clicking on the back button, or in some devices or versions of Android, swiping on the screen. An activity can also close itself with a call to the finish function. And then there are variations on this where a caller can close a called function, rather a called activity. Now, when an activity is closing, it has the ability to return information to the caller if the caller launched the callee, the second activity that performed some action, if it called it with the intention of having information returned. For that to happen, the activity must make a call to set result prior to it being closed. This can be called anywhere and at any time and any number of times, as long as it happens before the activity closes. Once it closes, whatever value was set here will be returned to the caller or to the original activity. It's important to note that Android itself can kill an activity. However, when it does that, it kills all components in the process, and it does this to do things like reclaim memory. So we don't think of it in the same way we think of it being triggered by the user or by code. So back to our application, we could give our second activity a way to close itself by simply adding a close button. And then adding a listener that says when the user clicks, simply call finish. So this will allow the closing of our activity with the click of a button. So I can launch second activity, and then I can close second activity. Launch second activity, close second activity. Now, if it were our intention to have information sent back from activities, from our second activity to our main activity, we would need to do two things. The first thing we'd need to do is not call start activity with an intent in the way that we have done it here. Instead, we would use what is called a launcher. And a launcher essentially looks something like this. We make a call to the function register for activity result. That's going to return an activity result launcher to us. Now we need to pass two arguments to the constructor for one invocation of this function. The first is a specific contract that describes the type of launch that we want to perform. Now, there are a set of predefined contract types that are available to us in the class activity result contracts, plural. And then we have a list available that essentially start from generic actions such as start activity for result to very specific actions such as capturing a video or creating a document or picking a contact. So we could start by simply saying start activity for result. This is a class, so we place the constructor invocation. And then the second argument is essentially a callback function that will be invoked when this launcher returns. In this case, we can pass in a lambda, and using the standard Kotlin syntax, we can place that lambda outside of the function call for clarity. Now here we see that my lambda receives one argument referenced using it, which is the standard reference for the single argument passed into a lambda. And the type of it is activity result. Now we'll see that activity result objects have a lot of data, but there are two parts that are interesting to us. There is the data and the result code. Now, before we can see what these are, let's look at the second piece of the puzzle when we want to pass information from a callee, such as second activity, to a caller, such as main activity. If it were the case that we wanted to pass information back from our second activity, then before calling finish, and that can happen anywhere in my code, I would need to make a call to set result. Now, there are two versions of the set result function. The first takes a single integer value called the result code. Now, this result code is simply a way to indicate to the caller what actually happened, or at least that is certainly the way it should be thought of. So it's a single integer value that is interpreted by the recipient to be an indicator of something. That something is essentially a protocol that you would decide on. You would decide on what any number means in the context of your application, generally speaking. That being said, there are certain predefined values that have meaning in Android simply because having activities from different applications communicating with each other is supported by the framework. So one of those standard values is result OK. This is a value that is defined in the activity class, and it has the value -1, but that's not important for our purposes insofar as you don't use this value for anything else. It simply is a reference to indicate from the callee to the caller that whatever action was being requested completed successfully. That means the caller, upon seeing that result OK was returned, can act in a manner that suggests the requested action was done. On the other hand, result cancelled suggests to the caller that whatever action was requested was not completed successfully. Again, that means the caller can act accordingly, whether that means informing the user that the action failed, or trying the action again, or some other remedy to this particular result. Result first user is simply intended to be a differentiator in case your goal is to use your own values, your user-defined result codes that are sent back to the caller. So setting result OK is basically telling the user, or telling the calling activity, that the requested action was fine. If, however, saying that the action, which had result OK, also has accompanying data, that would require that we use the second set result function that accepts an intent. This intent allows us to store data that can be accessed by the caller. In this case, we may essentially use or place any information that we would like that needs to be sent back using the same format that we did when we created the intent that was sent from the caller to the callee, from main activity to second activity. So if we wanted to place, let's say, extra information, then we would need a key and a value. In keeping with my original format, I would define the key in a single place. So I'll have another constant value, and I'll call this one result key. And in this scenario, it really doesn't matter if the values are the same, as long as I'm not using them in the same intent. And if we want to avoid that, then it's perhaps best we have separate keys. So I'll just call this one reply message, even though because of how I'm about to use it, it really doesn't matter. Now I simply need to go to second activity, and what I'm going to do here is directly on my intent object, I'm just going to call put extra. I'm able to do this because intents use something called the builder pattern, where it essentially allows you to chain function calls together. So put extra here will simply be reply, and I got the name wrong, so it's result key. And this is why it's important to use references where I wouldn't make a mistake about what I thought the key was, whereas before I typed result, but then as I'm about to retype it, I thought it was reply. If I was to use string literals, then I may very well have mistakenly typed reply here, and my program wouldn't work, because when my main activity looks for the value using the result string, it wouldn't find it. So here we can now pass some information back. Again, it really doesn't matter. It can be any of the types that can be placed as extra values. Now that I've called set result with these data, result OK, and this intent, this information is going to be sent back to the caller as the activity result object. Essentially, this it reference will now have the data element be the intent, which is the second argument of setResult, and result code will be the first argument that was passed to setResult. In the case where we only used setResult that took a result code, the data element would be null. As such, I could have logic that looks something like this. Well, this is going to be, I could insist that it has information, but if I'm not sure, because it's nullable, I could manipulate something here. So let us say my activity had a text view. I'll call this result text view. And then in my activity, I would have a reference to the view, which I would then initialize in my onCreate. I could now manipulate that result text view's text value with a call to get string extra result key. So I've now defined this launcher, but the next step is I have to use it. And I use it by going down to my buttons onClick listener. And instead of calling start activity with this intent, I will use my launcher dot launch with the intent. And what this now allows is for information to be passed, not just from the caller main activity to the callee second activity, as you can see here, but also when I close the activity, information will be passed from the callee back to the caller, as we see here. So this is the basics of using intents. So this is the basics of using activities in an Android application, starting an activity, closing an activity, as well as passing information from a caller to a callee and back from a callee to the caller using intents.